Hello, my name is Mason Berry. This is the first lab for Physics 2, charge tapes. Introduction. The main goal with this lab was to understand the interaction between two pieces of tape, and then simulate the reaction in a mathematical model. For the mathematical model, we will be using something called GlowScript, or VPython. It's an introduction to Python. It's pretty easy, and it's a good interface, easy to use. So yeah, this lab, the main thing is, think of it like this. So the setup for this lab, I want to elaborate this in the beginning. Um, there are two cups, and then you put a piece of tape in between the cups, and then you charge one of the. Sorry, you charge the two pieces of tape, and you lay one across two cups, and then you bring the other one near, and it almost looks like the one piece of tape across the cups is levitating. You charge this by doing something called like a U-tape. So you put a piece of tape down on the table and then another on top, and you pull the one off, and it gives it a charge. You do that to both, and you complete the experiment. So the concepts that were applied in this lab are Newton's second law and Coulomb's law. Newton's second law talks about F equals ma, so force equals mass times acceleration, and that's pretty important here because the pieces of tape are static and not moving, so the electric force between the pieces of tape is equivalent to the force of gravity. Then the Coulomb's law, this defines the electric force. K is a constant, that's 9 times 10 to the 9th power. Then Q's, Q1 and 2 are the charges. In this situation, the Q's will be equal, so you can, we have to assume they're equal. So it will be KQ squared, and then D is the distance between the two pieces of tape. The observed values. The first one is the length of the tape, which was 20 centimeters. The mass of the tape, which is 2 times 10 to the negative 4th kilograms. And then the tape width at 0.02 meters. Then final experiment results. The tape started to levitate when the other piece of tape was 0.7 centimeters or 0.007 meters. I also noticed the tape was attracted to other objects like my hand, the table. It was reacting to all the charges. Coding model part 1. The purpose of this first bit of code is to find the charge on one of the pieces. To find the charge on the pieces of tape. The result was 3.26833 times 10 to the 9th negative 9th power. So up here you see we have the constants that I mentioned earlier, and then here's r, which is distance, and then you have the force of gravity, mass times gravity, 9.81. Then you have the force electric, which is equal to the absolute value of gravity, because they are technically equal and opposite. So yes, to get the force electric in the positive direction, it has to be the opposite of gravity. Then you plug this all in, and then we use Coulomb's law, but we rotated it around so you could get the charge, which is the square root of the electric force times r squared divided by k value. Sorry, yes, I read that right. The purpose of the second model we did was to model the electric field between the tapes. I did not show the code for this because it was a lot. And then here's the electric field. This is us finding the strength of the electric field for that. And that's the same formula. Sorry, the formula is electric field equals K times the charge divided by R squared times the unit vector of R, which R is like the distance between observation point to your charge. Results, the magnitude of electric force was 1.6 times 10 to the negative 5th newtons. The magnitude of the gravitational force was 1.9 times 10 to the negative 4th newtons. Possible error could stem from loss of charges when handling the tape, such as the tape hitting your hand or hitting the table. Also, the tapes are not point charges, and they could have unequal charges. So that's why the results are probably not truly what they are, but that's okay with this experiment. Thank you for listening. Hope you guys have a great day.